Good day, new daily challenge. Today was only minimum cost to convert string number 2. It's hard level, and the level is hard because of this very strange constraints here and the new condition here, since we need to introduce the same indexes here. So if index are intercept, we could not do this. So this is a completely new solution, and let's start our implementation. So we define in infinite value here, we define n, which is len of source value, and we're building our graph here. So we're going to concatenate all strings here, original and set of change values. So we're going to create this one for I as in enumerate all strings here, and we need length of this one. Yeah, and we're going to build the matrix of lowest possible distances here. So defining infinite for in range n of m strings, and the next step is to initialize it all. We're going to iterate over m, and dist I is equal to 0. And let's build the distances here. So the distances are in the original changed and cost here, and we're getting this one C, and if lower than UB, then new one is assigned here. Yeah, like this. So the next step is our float Borshall algorithm here. And the next one will be dynamic programming over all positions here. So this is pretty complex solution here. So let's start with our float Borshall algorithm here, our iterations for in range m, and getting the distance, and for in range m, yeah, I and okay, and in this case it means there is no pass here, just skipping, and we will calculate all possible distances here. And we want to know it in advance in our next step. Pretty complex one. So yeah, okay, next step is our dynamic programming here. Our started here. Let's remove, probably leave this one. Okay, and let's start our implementation of our dynamic programming approach here. N plus 1. Initial one is considered 0, and iterating over range, and -1, -1, -1. Okay, and we're going to check if source I is equal to target I. So the symbols is equal. Actually, we just do nothing. In this case, we're comparing our strings here. T sub is equal to target, the same, and we're comparing substrings here, just skipping this one, and we're applying our dp with minimum possible distance here. Is distance u v plus I plus L in this case. And our result is actually if our 0 element is not infinite. In other cases it's -1. Let's try submitting it and see if it works here. So we got some syntax small error. Let's fix it here. And try one more time. We've got the range M here and fixing and trying to submit one more time. And small typo here. Let's change and try to submit. We got small issue with indentation here, so let's fix it and try one more time by submitting it. Yeah, and all cases passed here, so let's try to see if it works now. Yeah, thank you guys for watching. See you next day.